Okay, hi everyone. So here we have a very beautiful problem, all right, which is from Olympiad Math. So we are asked to show that the sum of the perpendiculars to the sides of triangle ABC is equal to the height of triangle ABC. Now, meanwhile, one thing is important, and that's the first information we are given, is that P is any point in this triangle, and then the second important thing is that the triangle is an equilateral triangle, so all the three sides are equal. So now they said that this P can actually be any point, and this statement will still be true. That's what we want to show. So we picked a point P, an arbitrary point, and now these lines are perpendiculars. That means they form perpendicular angle with all of the sides here. So let's call this one line A, call this one line B, and let's call this one line C. So in other words, what we want to achieve is that assume that the height of the triangle, okay, so let the height of triangle ABC be equal to H. And then let's call the side of this triangle, let's side AB. Okay, let's call it X. Okay, so in other words, what we want to show now is that we are required to show that the height is equal to A plus B plus C. Okay, so this is what the question wants us to achieve. Okay, so, and to do this, what are we going to do? Remember, we said that this side is X. So what it means is that here is also X, and that this one is also X. Okay, now, if the height of the triangle is H, let's do a little bit of construction again. So maybe something of this nature. So is our H. Okay, all right, so with what we have here now, we can try to make some small constructions here. Let us try to form the three triangles that we can see here to this other point C. Okay, so if you watch now, we have three triangles here. The first triangle is this one that we have here. That's triangle, okay, I can name it. Okay, so the first triangle is triangle APB, or we can call it ABP. Okay, so we have triangle A, that's this one, ABP. Okay, and then we have another triangle. Let me call it triangle ACP. So ACP, and then finally we have another triangle BPC. Okay, so we have BPC. Okay, or we can call it BCP, any of that. All right, so now if you watch carefully, now you can see that we can actually determine the area of this triangle, and we are told that area of triangle is always equal to half base times height. Okay, so which you can write as base times height over 2. Okay, so if we bring that here, so it implies that the area of this first triangle here is going to be the height there, which is A, multiplied by the base. The base is X, all over 2. So we can keep this as equation 1. And if we come to this other equation, to this other triangle ACP, you will discover that the area is also going to be the height, which is B. You can see the height here is B, and so B times the base. The base is also X, all over 2. You can call this equation 2. And now for this one is also going to be similar. So that's triangle BCP or BPC is going to be, the area will be the height. In that case, the height is C, which is here, multiplied by the base, which is also x, all over 2. Call this equation 3. All right. So now the implication of this is that, recall that the area of this whole triangle is going to be the sum of the 3 areas that we just saw now, because of course these 3 triangles make up the whole triangle. So the area of the whole triangle, area of ABC, of triangle ABC, will be equal to the sum of all this, which is ax over 2. All right, so that means the area of triangle ABC is therefore going to be equal to, so here you can see x over 2 is common. So let's bring out x over 2. So we will have, if you bring out x over 2 here, you have a plus b plus c. All right, so we can keep that there. Now come back here. Now let us also try to get the area of this on its own. Now using this same formula, the height, remember we are told that the height is h multiplied by the base, which is x, all over 2. Okay, so now here we have that the area of the triangle ABC is h times x over 2, and here the same area is equal to this. So if we equate the two of them, if we call this equation 5 and call this one equation 4, okay, so equating 4 and 5, we are going to get that hx over 2 will be equal to this side, which is x over 2 into a plus b plus c. All right, and so from here we can finish up and get what we want. Quickly, you can see x, we cancel x here, and 2 here is below. You can also cancel these 2. Therefore, we have that our h alone is equal to a plus b plus c as required. And that's what they asked us to do, to show that h is equal to a plus b over plus b plus c. And that is the solution to this problem. Kindly subscribe to my channel. We'll see you in our next video. Bye.